So you may have seen this experiment before, where you put pepper in a bowl of water, add some soap, and the pepper flies away from the soap. Now, all you need to do this experiment is a bowl of water, some soap, and some pepper. But why does this happen? Well, it has to do with surface tension. To understand surface tension better, let's take a look at a rubber band. If you stretch a rubber band, there's going to be tension after you stretch it. Now, what do you think would happen if you were to break this tension? As you can see here, if you cut a rubber band, the rubber band flies apart. Before the rubber band was cut, the tension forces coming from the edges of the rubber band canceled each other out. But after the rubber band is cut, these tension forces no longer cancel each other out, and they force the rest of the rubber band to fly towards the edges. This is similar to what happens with the pepper. The tension forces coming from the edges of the bowl are canceled out by the tension forces coming from the opposite side of the bowl. But once the soap is dropped in, the soap breaks up the surface tension of the water and causes the non-soapy water to move toward the edges. So this phenomenon is just like the snapping of a rubber band. The soap breaks up the surface tension of the water. The technical term for a chemical that breaks the surface tension is called a surfactant. So soap is a surfactant. This is also how soap bubbles form. With just regular water, the surface tension would be so great that the bubble would collapse in on itself. However, with just the right amount of soap, a soap bubble can form which won't collapse in on itself, yet there will still be enough surface tension to keep it intact for some time.